Now, computing z-values, we use this little formula here to compute them. We take each x minus the mean and divide it by the standard deviation. So if the standard deviation is 10, so if I wanted to find the area under the curve between 120, what is the probability that I would select a number at random and get a number between 120 and 135? I would compute the z-value of that number 135 as 1.5, and then I could look that up in the table in the back of the book. 1.5 translates to an area of 0.4332. So the probability of selecting a value between 120 and 135 is 0.4332. Now the table in the back of the book gives you the area between the mean and another number, as we just saw. But what if I want to know find the probability of getting a value above 135? Well, above 135, table can't give us that directly. So we have to rely on a little bit of knowledge about the table. The fact that 50% of the curve lies above the mean. So if 50% of the curve lies above the mean, and we know that 43.32% are in here, then it must mean that what's left over from 50% is in here. So therefore, if I take 0.4332 minus zero point 0.5, I'll get 0.0668. So that is the probability of getting a value above 135. Anytime you have to find the probability of getting a value in the tail of the distribution, you simply subtract the probability you can find in the table from zero point 0.5. What if I wanted to know the area between 100 and 135? What is the probability of selecting a value at random and getting a value in that shaded region? Now, to use the table in the book, the table can give us this area here, which I've labeled area 1. The table can give us this area, which I've labeled area 2. So ordinarily what you would do is you'd find the area between 120 and 135, which we've already found to be 0.4332. And we would find the area between 100 and 120. Now if you look over here, I've found the z-value, and you'll notice the z-value is a negative 2. Negative z-value simply means we're below the mean. The table doesn't care whether that z-value is above or below the mean because all areas are positive. Well, it ends up that this area is 0.4772. So the chance of getting a value in between here and here is 0.9104. These two areas added together. What if I wanted to shade half the curve? For example, if I wanted to find the probability of getting a value above 100. This area is above 100, but this entire area, if I'm shading half the curve, I'm going to basically, half the curve is equal to 50% or zero point 0.5. So I'm just going to add 0.5 to whatever this area is that I can get from the table. And in this case, the probability of getting a value above 100 is 0.9772. This 0.5 plus this 0.4772.